So today we're going to be talking about chemical reactions and what each piece of the reaction is and how to make sure that this reaction is balanced. The goals for today are going to be that by the end of this lesson you should be able to identify the reactants in a chemical equation, identify the products in a chemical equation, and also be able to demonstrate on how to balance a chemical equation. So, chemical reactions. These are things that produce a whole new substance with new physical and chemical properties. If you remember way back to the first week of this class, we talked about different physical properties and chemical properties, and how if it's a physical property, it's something you can see, and it doesn't change if something happens to it, whereas chemical properties are something that causes it to change and you can't get it back to the way it is. With a chemical reaction, the substance you had before changes into something completely different. So we've already counted atoms, but I wanted to give you a little bit of a refresher because we are going to be balancing, which involves a lot of counting atoms. So the chemical formulas show the elements and the number of atoms of each element in a molecule. For example, right here we have H2SO4, which is sulfuric acid, and each of the elements we have in there is hydrogen, sulfur, and oxygen. And if you remember, the subscript here is what tells you how many atoms of each of these elements there are in this compound. So we have 2 hydrogens, 1 sulfur, and 4 oxygens. And adding a coefficient tells us the number of molecules of that compound that we have. And if you remember, take this number and multiply it by this number to get your atoms for each element. So we have 2 molecules of sulfuric acid, and now looking at the atoms for each of the elements, if you remember, the elements are hydrogen, sulfur, and oxygen. For hydrogen, we have to take 2 times 2, which is 4. So we have 4 atoms of hydrogen. We end up with 2 atoms of sulfur and 8 atoms of oxygen. Now getting into the nitty-gritty of the different pieces of the chemical equations. The chemical equations are basically a description of our chemical reaction using different letters and numbers. It's basically a reactants versus products. Looking at the equation we have down here, we've got CO2, which makes CO2. This is what I was talking about when I said that it was a description of the chemical reaction using letters and numbers. It's explaining what is happening because sometimes we can't physically see it. Most of the time we can't physically see what's happening as we're causing these things to change, or they're changing on their own. So this is a way for us to understand what is going on at the molecular level. So the different parts of the equation, we have the reactants. This is one or more substance that enters the reaction, and this is going to be on the left side. So it's going to be this side right here. We have the arrow, which is what we call the yield sign. It's also basically like the equal sign in math. So that's this piece right here. And then we have the products. This is one or more new substance that is formed during the reaction, and it's on the right side. So this is what comes out of the equation. So that's going to be this right here. So if you think about it this way, the reactants are what goes into the equation, the products are what comes out. And the arrow is telling you the reactants are creating the products. So another thing that we have to know is that chemical equations have to be balanced because they show what happens to all the atoms that are involved in this reaction. So basically saying we have to have the same number of each atom on both sides of the equation. Looking at the picture I have down here, you can see that we have 4 irons on the reactant side. Remember, the reactants is this side here. And we have 1 atom of iron on the product side. Basically saying we don't have a balanced chemical equation for this example. I'm going to show you how to balance it, but I just want you to be aware that this is what I mean when I'm talking about balancing. We have to make sure that this number and this number end up being the same. So first we have to learn about the law of conservation of mass. This states that matter cannot be created nor destroyed. The matter that we have in the universe is all that we have. So in chemical reactions, the quantity or amount of each element does not change, meaning that each side of the equation needs to have the same amount of each element. So to sum it up into simple words, they need to have the same number of atoms on both sides. So how do we balance? Looking at this chemical equation I have right here, it's Na plus Cl2 makes NaCl. We want to look and see, alright, are there the same number of sodiums and chlorines on both sides of the equation? Well, if we look at sodium here, remember sodium is Na. On the reactant side I have 1. On the product side, I have 1. So we have the same number of sodiums. But what about chlorine? So on the reactant side, chlorine has 2. On the product side, it has 1. So no, these are not the same, which in turn means that it's not balanced. So the balancing rules. As I've taught you from the law of conservation of mass, matter cannot be created or destroyed. One big, very important thing, subscripts, remember these are the subscripts, these cannot be added, removed, or changed. So if there is a subscript in your chemical equation, that is there forever. It's stuck, it's locked into place, there is nothing you can do to change that. But you can change the coefficients. Remember, the coefficients are the number in front of the compound. These you can add, remove, change, do whatever you need to make your atoms the same. So here are the steps to balancing the chemical equations. First, figure out the number of atoms you have for each element. That will help you identify which elements are not balanced and where you can go from there. The next step is going to be picking an element that isn't balanced that you want to try and balance. Then you're going to add coefficients in front of the formula that has that element and adjust your counts for your balancing setup. Then finally, you're going to continue adding, changing, tweaking coefficients in order to get the same number of atoms for all of the elements on both sides of the chemical equation. I know I just threw this all at you and it sounds very, very hard, but we are going to be doing a few practices so that you can kind of see and visualize exactly what I'm talking about. I am going to give you a couple hints that should help you through the balancing as well. First thing would be to start with the elements that have the smallest number of atoms.